Okay, welcome back students. Today we will be solving the rest of the part of the problem that we took in the previous video regarding eccentric welded connection. So this was our question: determine the maximum stress in the weld of the bracket connection if weld length size is 8 mm and determine whether the connection is adequate or not. This was our member, this was our bracket connection on which an eccentrically load was applied on this member or on this gusset plate. And what we did was we had calculated the location of the CG, that is we had calculated x dashed and y dashed, which are the location of the centroid of gravity with respect to y axis, y axis, and with respect to x axis. Okay, I hope those calculations are clear. I urge you to do it yourself, try it out yourself. Now today we will be calculating the polar moment of inertia. Okay, let me just write down what is the polar moment of inertia. The polar moment of inertia is given as, or it is denoted as IP, and it is nothing but the summation of moment of inertia about x axis and y axis. Okay, so in order to calculate this IP, we have to find out Ixx and Iyy. All right. So how to calculate Ixx? Let's see. Just give me a second. All right. So this was our bracket connection, and this value x dashed was equal to how much? 37.5 mm. Okay, and this value y dashed was how much? It was, I will just decrease the size of my font. Okay, the y dashed value came as 150 mm. Since it is symmetric, the welding is symmetric about this x axis, so y dashed is 150 mm, which is equal to 300 by 2. Now we should calculate Ixx. So moment of inertia, the formula for a rectangular member, suppose this is my rectangular member, and if an axis is cutting this member along this dimension, suppose this is B, and this dimension is RD. Okay, so what is my formula? My formula for moment of inertia about this axis will be given by BD cube by 12, BD cube divided by 12. Okay, so let's see how to calculate. Now first we are calculating moment of inertia about this x axis. So we had considered 3 strips. This is our strip 1, this is our strip 2, and this strip below is our strip 3. This is 1, this is the second strip, this one is our third strip. Okay, so for the first strip, what do we have? We have B as the throat thickness. We are taking B as the throat thickness, okay, which is equal to 5.6. all right. D is how much? D is my this dimension, the length of this second strip, it is 300. So 5.6 into 300 cube divided by 12. If this is a rectangular, if we assume it as a rectangular section, so the moment of inertia about this axis is BD cube by 12. Now we have this section. This is also another rectangular section whose a longer dimension can be taken as the longer dimension can be taken as 150 mm, and the shorter dimension is taken as 5.6 mm, which is the throat thickness. Now, in this case, it will be a little complicated. Okay, suppose I have a rectangular member here, which is at a distance of, suppose this is the axis, not the distance. Suppose this is the axis, this is my x axis, okay, and my rectangular member is located at a distance, at a certain distance from this axis. So suppose this is the central line, and this distance over here is, suppose it is r. Okay, suppose this is r. So whenever we are calculating the moment of inertia with respect to an axis which is not passing through that member, through the body of that member, we have to adopt the theorem of parallel axis. Okay, in that case, in this case, my moment of inertia will become how much? My moment of inertia will become BD cube by 12 plus A into R square plus A into A R square. Okay, let me just drag it down. Okay, so this is my formula for moment of inertia whenever the axis with respect to which we are calculating the inertia is not passing through the member. So this is, this first strip and this third strip is that axis. These axes are not passing through the x-x axis. I mean, these strips are not passing through the x-x axis. So we have to calculate it using this formula. So see what I have done. In this case, the x-x axis is basically it can be assumed to be passing from the shorter dimension, which is 5.6. Okay, so my BD cube by 12 will be equal to 150. This is my 150 mm. Okay, this is my 150. Okay, 150 into 5.6. Okay, this dimension I have assumed it to be 5.6 mm. So 150 into 5.6 cube by 12, this is my BD cube by 12 portion, and this portion is my AR square. Okay, this is my AR square. So what is A? A is nothing but the area. Area is how much? Area will be again this 150 mm. Okay, into 5.6. So A is 150 mm into 5.6 into 150 square. Now what is this 150 square? If you look at this diagram, see, if you look, if you see this diagram, this axis, x-x axis, is lying at a distance of 150 mm from this strip. Okay, so my r here will be this AR square. The r here will be 150 mm. How? Why? Because this x-x axis is lying at a distance of 150 mm from the strip 1. Okay, so that is how we are calculating the moment of inertia. And one more thing, we have calculated the moment of inertia for second strip, we have calculated the moment of inertia for the first strip, and we are simply multiplying the moment of inertia calculated for the first strip with 2, because the third strip is also located at a similar fashion like that of the first strip. Okay, so we are multiplying this entire value, BD cube by 12 plus AR square, into 2. So now my after calculating this big expression, be very careful with this expression, my value is coming as 50.4 into 10 to the power 6 millimeter to the power 4. Okay, so now I will just erase all this portion. Okay, now the next thing that we have to do is we have to calculate the moment of inertia about the y axis. Okay, we have to calculate the moment of inertia about the y axis. Let me just draw it so that you can understand it better. Okay, so this is my y axis is passing somewhat through this location. Okay, and this distance that we have here is how much? It is 37.5. Okay, this distance is 37.5 mm. All right, this much. And this length is how much? This length is 150 mm. Okay, this length is 300 mm, right? And this length here is 150 mm. Okay, now let's see how to calculate Iyy. Now first we have this strip. Okay, we have this strip, 300 mm strip. Now see, this y axis is not exactly passing through the second strip, through this 300 mm strip. So what we have to do, we have to apply that parallel axis theorem here. So again we have to apply that formula, bd cube by 12 plus ar square. So in this case b is going to be 300. Okay, I will again write down bd cube by 12 plus ar square. Okay, so here my b is going to be how much? It is going to be 300. D is my throat thickness, 5.6 cube by 12. This is my bd cube by 12 portion. And ar square, a is the area. Area is how much? It is 300 into 5. It is 300 into 5.6 mm. Okay, and r, this distance r is the distance of this strip from my y axis. So the distance of this strip from y axis is how much? It is 37.5 mm. So that is what I have written here. I think this is clear. And now we have come to the first strip and the third strip. So for the first strip, so the first strip here, see the y axis is passing, it is not exactly passing through the centroid of this strip. So again for this strip we have to apply the parallel axis theorem. This portion has to be calculated. Okay, so in this case b is how much? B is going to be 5.6 mm and this length is going to be 150 mm. Okay, so bd cube by 12, 5.6 into 150 cube by 12 plus, now we have to calculate the area again. My area is 150 into 5.6 into, see the location of centroid, sorry, the location of centroid of this 150 mm strip is lying in the middle somewhere here. So this distance is how much? This distance is 75 mm. Okay, sorry, so this distance is my 75 mm. Okay, so what is the distance of this y axis from the centroid of this 50 mm strip? It is nothing but 75 mm minus 37.5. So that is what I've written here. So this is a into r square. Done. Now the same thing, for the third strip also the calculation will be same. So I have multiplied this entire expression with 2, and that is how we are calculating the moment of inertia about x axis and moment of inertia about y axis. If in case you are having a problem understanding as to how it is being calculated, you can consult me. Okay, so once we have calculated Ixx and Iyy, it is very easy to find out the polar moment of inertia, which is equal to the sum of the two. This comes out to be 58.3 into 10 to the power 6. Okay, so today we are ending the video here. Just go through the calculations, try to do it by yourself, and in case you don't, if you don't understand, you consult me.